How about the classical mechanics? Okay, we demonstrated, honestly, we presented the possibilities or the motion of particles at the smallest dimensions, like a structure of atom or orbitals, electrons. And it is not, we investigated and we inferred, we said that it is not easy to determine which is about their motion, their behaving, or their replacement, or maybe the transformation of energy, something else. At the systems or the dimensions, it is not easy, so we are using the possibilities and the equations. Let's talk about the classical mechanics, the visible world. That time, it will take a shorter time. If we are going to have a comparison with the quantum mechanics, yes, that will be more easier, but in fact, they are also the other parts which are essential to understand this mechanics, quantum, astrophysics, or maybe the macrocosmos, or the other departments which are bifurcated in physics. So to speak, in that video, after the investigation of possibilities in quantum mechanics or the dimension, we are talking about the mechanical physics, the Newtonian physics, which is the essential and important one. So honestly, this mechanical physics and the events that is experienced by mechanical physics are the pioneers for the other explorations and explanations, so to speak. Yes, it is honestly the first time we had better to understand and investigate the motion of laws and the other classical mechanics laws. What kind of possibilities we may investigate, and also we may think about at the mechanical physics. What kind of things? For example, at the classical mechanics, we are doing observing the vehicles, okay, the planets that is orbiting around the star or our sun, or maybe the electrical field, the magnetism, or maybe the transformation and the conversation of energy with the environment of it, like a place, like the other things, effects, like a fraction force. Also momentum, the collisions, we are investigating. Also, for example, the vectors, the motion of laws, the Newton laws, that the first law, second law, third law, and maybe the momentum, maybe, as I said, the effects of force, which is about the systems and the objects and their import, many things at mechanical physics. But I will explain it in a nutshell, not long, it will not take a long time. For example, if you are looking for a system in the mechanical physics and the other things, like observable things, not at light speed, but the normal physics laws occurring. Yeah, we are talking about for example, there's a car is just passing and your eyes are observing it. What do you see? In a classical mechanics, yes, we know that the friction in the tires, because of the circling and turning very fastly, affecting, and this is why the velocity of car is going to be the increase as time passes. If there is no force between the engines, that will not create an acceleration towards the, or maybe to the which is let me say that, which is at the same aspect with the velocity. This is why the friction force or the friction is opposite for the motion. For example, this is a possibility. What kind of conditions that the vehicle or the system is being, or maybe what is going to be happen, or is there anything else that occur in the system? If there is something that is occur in the system in the classical mechanics, your deductions or maybe determinations and also your demonstrations towards the system is going to be changed, because the values are going to be changed. The system will be affected, so to speak. This is the other possibility. As I said in the previous video, the possibilities we will talk about is just smaller ones, not smaller, short ones, just to make it possible or understandable to understand or maybe to observe just the little parts of systems, because many things can be there. The air fraction, or maybe the you know that this is why if there's a robin, there should be going to a fraction, or maybe not just that. For example, if you are looking for the energy of systems, which is not like a wow, it's really hard to continue in English. In my own language, it's easy. Okay, for example, there's a system which is the topic or the issue we are intended to do and observe is the energy and its conversation with the potential and the kinetical, or maybe the gravitational energy, you know, that the potential. So you had better to investigate everything. Like for example, at the Earth, you are on Earth, at the surface of Earth. You have maybe for the height level, if you choose that, you have potential. And also there is a gravitational force between you and the Earth that occur in between you. The values are same, but the accelerations are different because your masses are different. For example, this is a possibility we can call. Like we are investigating the effects on the object in the classical mechanics, not like a quantum mechanics. I said, yeah, the light speed, the locations where it can be, or the orbitals, which is true, or the speeds, the momentum, or the energy levels. For classical mechanics, I say the effects on the object. These are the possibilities. For example, you had better to investigate. So they are going to be complicated. If you are all evaluate all of them in the same time, this is going to be complicated. So you cannot easily understand the event, and soon afterwards you cannot explain it with the mathematical and physical formulas. This is why we are using in classical mechanics like investigation the object with like one smallest point, which is also causing that the system is going to be more understandable, and this is why you can investigate and also try to see everything in the one point, and we are explaining and also we are presenting them with the vectors, which is making these observations and experiments easier to understand and to calculate. This is why, as you can see in the classical mechanics, the possibilities are important, but these possibilities are like effects on the object, so to speak. Yeah, that's all. And for the macrocosmos, this is going to be a little bit harder because the objects at the macrocosmos are enormous, with contours, the radius, diameters, the masses, of course. I should not ignore that sentence. Mass, and maybe the gravitation effects, the space-time tissues, and their curving at the effects of the dimensions of space. This is physics. So yeah, in this video, in that presentation videos, we investigated the possibilities. The other one will be about the Schrödinger equation, which is about the possibilities in the quantum. And maybe at the end of that video, we will talk about a little bit the possibilities in the macrocosmos. But the importance is, yes, I honestly presented them, and this is time for demonstration.